Right, so welcome to the lecture today. My name is Walter Zeug. I am also part of the department Bioenergy and a colleague of Daniela Trehn and Alberto Besama. And today we will expand a little bit the scope of the classical material flow management by some approaches on how to define and actually measure not only ecological, but also social and economic sustainability. And here you can see the course plan of this year, of the semester. I think you know it. There will be two more presentations on the 12th and on the 19th of January. And today we start with first a look at the fundamental problems of sustainability. I think it's very interesting and very necessary to have a look at this to understand what could be relations of society, ecology, and economy, because understanding those relations is very, very important and essential to actually assess social, ecological, and economic sustainability. And at the end, to give you some practical insights, I give an example of a case study I did recently. So let's start with the fundamental problem of sustainability. And you should always ask yourself, what actually is this fundamental problem of sustainability when you're talking about sustainability? Because sustainability has become a widely used term also without more or less meaningful context. So on the left-hand side, you can see the planetary boundaries in Germany in 2019. And what is obvious is that we in Germany, but also as humanity or globally, we are currently transgressing several planetary boundaries. And for example, you can see in Germany, we transgress all planetary boundaries except land use change and blue water. But of course, we have a much too high ecological footprint. We have a much too high material footprint, the CO2 emissions, of course, phosphor, nitrogen. So all those planetary boundaries are transgressed. And those planetary boundaries, they represent the biocapacity of our planet. And the process of calculating such a capacity is quite complex, but you can say it's like the regional and global capacity of an ecosystem to produce biological resources and to absorb emissions and waste from our society, from our economy. So we should actually not transgress those biophysical boundaries, because this can lead to strong feedbacks, and those feedbacks, they can trigger tipping points, and those tipping points are, when we trigger those tipping points, then things get very, very difficult to handle and very, very difficult to predict. And the impacts which transgressing planetary boundaries will have on our societies, they will be massively negative, and in some cases abrupt, and that's for sure. So it's uncertain how it looks when we are transgressing those biophysical boundaries, but that the impacts of transgressing those boundaries are very, very negative, and we should do everything we can to not transgress them, that's for sure. So on the other side, we have a thing which you can call societal needs in Germany. So what are societal needs? Societal needs change over time, and they are, of course, globally different, but you can say these are things like life satisfaction, health or life expectation, nutrition, sanitation, income, access to energy, education, social support, democracy, equality, employment, something like that. So it's just to give you an orientation. And in Germany, we have the case that we are fulfilling most of those social thresholds and social needs. But And this has to be clear, of course, that this does not mean that in Germany anything is like perfect in a way, in a social way, but compared to a global scale, it's more or less the case. But keep in mind that a lot of regions in the world lack most of those basic social needs. And things which are not here, for example, and this is something which, of course, is a problem in Germany, but is like not part of those social threshold here, that, for example, the risk of poverty, so for precarization, this process is called, is increasing also in Germany in 4 years. You all know some of the statistics that which is 10% of your population own more than half of the total wealth. So we have planetary boundaries and societal needs. And when you have a look globally, you see that here is a map of the planetary boundaries and how they are transgressed. The greener, the better, and the more yellow, the worse. So you can see that most of the industrialized countries are transgressing planetary boundaries a lot. And when you compare the fulfillment of social needs to that, so the darker blue the countries are, the more social needs are fulfilled, and the lighter blue the less social needs are fulfilled. You can see that we have an obvious problem here. And this problem is that the fulfilling of social needs seems to be directly coupled with transgressing of planetary boundaries. And that's very bad news, because we not only want ourselves to have, or in our societies, to have the social needs fulfilled, but we also want to fulfill social needs of all those people and all of those countries which do not have such nice social standards as we may have. So the main challenge is, at the end, to decouple this seemingly coupled relationship between fulfilling social needs and transgressing planetary boundaries. And to give you a number on this social ecological relations in Germany, so social ecological relations means exactly this relation between social needs and planetary boundaries. In Germany, our environmental footprint is 3.3 times its biocapacity. So we are transgressing the planetary boundaries by about 3.3 times. So it's not like 1 point something or so, it's 3.3 times. So it's not only something like one decoupling, but actually we need a double decoupling. Double decoupling means we need to, at the one hand side, decouple the production from resource use. That means that the things we are producing are consuming less resources. But on the other side, we also need to decouple social needs from production. Because in our society now, in capitalism, social needs and the fulfillment of social needs is directly coupled to the production of goods. And when the production of goods is directly coupled to the resource use, you get exactly the social ecological relations we are observing today. So at the end, to tackle this challenge of this factor of 3.3, it is not only technical means which we need to implement, but we also have to address dimensions of inequality, of injustice, and all of that, because additionally to that, the technical decoupling itself is not plausible. So there are just not plausible studies or a plausible empiry, a reality on where we can see that it is possible only by technical means to make such a factor of 3.3 happening. So that we produce like the same amount of smartphones, the same amount of computers, the same amount of cars with 3.3 times less resources. That's just not possible. So we need a socio-ecological transformation. It means a societal transformation, not only of our things, how we are producing them in detail, not only technical, but we need a societal transformation. And one option of this could be a social ecological transformation towards bioeconomy. And bioeconomy means the efficient and innovative use of renewable resources and this social transformation. But the problem is that sustainability is not an intrinsic characteristic, but rather promising potential of bioeconomy. That means we have to assess the risks and chances of the bioeconomy, and we cannot just assume that everything gets better when we are just doing bioeconomy. And bioeconomy has to tackle several of the societal challenges simultaneously. And of course, there are a number of conflicts which go hand in hand with it. So the one thing is we have to reconsider our means and ends of our economy. Because also in a bioeconomy, means and ends are quite unclear. In a minute, we discuss it a little bit more in detail. The other thing is that economic growth is leading to increasing environmental impacts. And you have just seen that we have the ecological necessity of reducing environmental impacts. So also economic growth in bioeconomy or a bioeconomy additionally to a fossil economy. So not substituting our economy we have by bioeconomy, but making our economy as we have it today, plus additionally bioeconomy. This would, of course, increase environmental impacts, but we have to decrease them. Of course, we have also a competition about resources, for example, land and agricultural crops between, for example, nutritive and energetic and material use. And of course, there are trade-offs between economic, ecological, and social effects. And when we are discussing all of this, also the bioeconomy, we have to keep in mind always that there are regional and global shifts of negative effects to other regions. So it's the same with the fossil economy. When we are producing cheap textiles, cheap clothing in Bangladesh or somewhere, we are just shifting, externalizing negative social effects to other countries. And we have to be aware that this is not happening when we make such a transformation to bioeconomy. So to understand those relations between society, ecology, and economy, we have to really take a step back, and we really have to reconsider, or actually for most people to think the first time about what actually is nature and society. And is there something like nature versus society? Just imagine we have those two spheres, nature and or nature represented by planetary boundaries, and the society represented by its social needs. Then some terms come up. For example, of course, you know the term ecology, which is like the idea of natural cycles. So those natural cycles, those ecology also have every organism or every metabolism on Earth has this ecology, and it's something like a self-organization process with its environment. On the or with its surrounding nature. On the other hand, we have the term of environment, and environment is more an idea of an external surrounding. And it's not, we as a society, we have not like a metabolism like an organism, like a worm or a deer or a rabbit or whatever, but we have society-nature interactions, which are mainly consisting out of material and energy flows and like decolonization and valorization of natural processes. So we cannot compare ourselves with something like an animal, because an animal is not creating and transforming its surrounding. So an animal is depending on the nature and planetary boundaries and everything which is surrounding it, but we are transforming our surrounding, our environment. That's the big difference. And there are also two terms of sustainability. The one term is more sustainability as society has to subordinate itself under something we call nature, and that nature has an intrinsic value. And this concept is oftentimes called ecocentrism or strong sustainability. And there's also the term of sustainable development. And sustainable development represents for a society that uses nature. So we are valuing or using nature for its economic value it has to us. And this concept often is called anthropocentrism or weak sustainability. So besides those concepts, or with those established concepts, there is a fundamental problem, because let's go back, with having sustainability and a sustainable development on each side, or to say nature versus society in a way, leads to a polarization. So we are getting a dualism of whether we have to subordinate ourselves under nature, or society has to use nature. And things are discussed between those two poles. But this is not a very productive view of the world. And by the way, it's also not a very correct one. So which is the more interesting aspect is to understand not nature as itself or society as itself, but to try to understand the relations between society and nature. And it also gets clearer when we actually think about what nature and society is, because what nature is, that every time results from what society, that means culture, technologies, etc., are not, and vice versa. So there is a relation between society and nature, because there is actually no nature without society. It just makes no sense to talk about nature when there is something when there isn't something like society. Because what we describe as nature is mostly what society is not. So they are constituting, nature and society are constituting themselves, each other, in a relation. And also in the Anthropocene, so in the time age, or in the age of man creating or shaping our world, there is in fact no untouched nature. And in fact, if you take the argument from before seriously, there was never an untouched nature before, because as long as society exists, there is no untouched nature. And when society does not exist, even talking about nature doesn't make sense. So don't think about nature as something which is like untouched or so. And the important thing is that society and nature constitute each other in their relationship. And this relationship, this is framed by the concept of societal relations to nature. If you are interested in this background of what societal relations to nature mean, have a look at the literature I give you here, and you can also see it in detail at the end in the references. So let's have a look on how social relations to nature are actually determined. So our social relations to nature are determined by metabolisms, and those metabolisms have different dimensions. There are material and energy flows. We have our economic system, there is a T missing, and we have those social needs. And those metabolisms, that means our form, the form of our metabolisms, the form of our social relations to nature, are shaped by economic processes. So what is actually economy? You all know, or may not, but economy is understood as a temporarily and geographically different, that means also changeable, social system to actually satisfy social needs as ends by means of natural resources, human labor, and technologies. So the very important thing here is not only that economy is to fulfill social needs as ends by means, but also that economy is not a natural thing. Economy is very specific, is historically specific, and it is not there by nature, but we as humans, as a society, we are actively shaping or are passively shaped by our economy. So we are coming now to a little exercise, and I would like you to first propose some questions. Is anything unclear, or is there anything which we should discuss in more detail for you to understand it better? All right. If not, then let's make a little exercise. You see here economy, nature, and society represented by those three spheres. And you also have like an arrow. This arrow is means for ends. That means, how are we organizing means and ends? So in which direction? So at the end of the arrow stand the ends, the social needs. And we have the social relations to nature as our relation of society, nature, and economy. And I want you to please make up your mind on how to organize those three spheres and the arrows. So just find how would you draw it? How would you organize those spheres? You may have some pictures in your mind, and I just want you to maybe take yourself 5 minutes and to make a little drawing on your desk and just try to shape, to organize those spheres in a meaningful way. Unfortunately, I cannot make something like unfortunately, I cannot make something like that you can draw here, I think. No, there's a drawing. Can you here's the whiteboard. Can you draw on this whiteboard? Are you able to do that? Now you should be able to do it. Okay, unfortunately, I cannot give you the presentation at the same time, but yeah, maybe just have a look at the PDF. But if you still have it in mind, just find a meaningful meaningful concept for those three spheres of society: ecology or nature and economy, and how the social relations to nature and the means and ends are maybe there. And feel free to activate your microphone and talk to each other. So I see 2 circles. Maybe we need a third one somewhere. And maybe you should also put, yeah, exactly. All right. I think you're finished. Not bad. Does anybody want to you, Hannah or Jen? I think you already, or Julian. Does anybody of you want to comment on that? So, what are your thoughts, and maybe what are open questions? I will not force you, so I think it's more or less clear. Jen, is it a question or? Yeah, exactly. Ah, okay. Yeah, yeah. Okay. No, that's fine. Let's just leave it here. Let's just leave it at this point. This is one way to see it, and it's actually not a bad way to do it. So you have done it intuitively in a good way, because what you are thinking here is of the relations. And let's just go on with the presentation, and I will show you what concepts are there in the discourse and what advantages and disadvantages they have. So let's go back to the presentation. All right. So there are, for example, two dominant or two things which are in the status quo very popular. On the left-hand side, you can see the three-pillar approach, and this is the very dominant model. So you will see this concept in a lot of publications, in a lot of concepts, in a lot of websites. And we will have a look at this later, because just keep it in mind. You have like this sphere, society, nature, economy, and there are some points of interceptions. So when you're thinking about maths and the theory of entities, the theory of entities, you can make something with those interceptions. So you know this scheme from maths. So it seems like there is a lot of sense behind there, but we will see that if it gets really practical, you have a lot of challenges for implementing the three-pillar approach. And also the three-pillar approach is also often called a reductionist model of interlinked systems, because what you don't see here is really thinking about relations. You just see some kind of intersection. On the right-hand side, you can see a specific configuration which is specific for the societal relations to nature in capitalism. And it's not my own idea. You find such a configuration in some publications, for example, in the new United Nations guidelines for social lifecycle assessment. So there are planet, somehow as a nature, the people, and profit. So economy equals profit in this interpretation. And of course, in capitalism, which is a very specific form of economy, that's really the thing. Economy is equals to profit, because economy, or those metabolisms, our economic actions, our economic activities only take place if at least at the end you hope for something like profit. So, and that's why economy equals profit in some of the interpretations. But there's also another form of how to make this configuration, and that's something I came up with, and it's, I think, a good or a better starting point for our sustainability assessment than all the other concepts before. You can see here society in the center. Why? Because what we want to do is we want to fulfill social needs. And you can see nature surrounding all of that. Why? Because nature stands for our resources, for our planetary boundaries. So our societal relations to nature, which we are discussing, should be limited by planetary boundaries, as we discussed it before. And economy is a social system between society and nature. Why? Because economy is shaped by society, but also economy is shaping society. And economy relates nature and society. And when you're thinking about such a concept and such a configuration, you can also make, at least I would say, meaningful definitions of what actually social, ecological, and economic sustainability is. Because if we want to assess social, ecological, and economic sustainability, we need to define this, especially when we are doing LCAs on that. So we would say, and this is just to propose a definition here, social sustainability is the long-term and global fulfillment of societal needs and human well-being as an end. And that's why it's at the center, and it's at the end of our means ends arrow. Ecological sustainability is the long-term stability of our environment as a basis of reproduction within planetary boundaries. And now the important thing, economic sustainability stands for technologies and economic structures which are so efficient, effective, and just provisioning systems that they are relating societal needs and nature in a meaningful way. So the definition of economic sustainability is to provide the economy, for example, a bioeconomy and a societal transformation, which actually enables us to fulfill our societal needs within our planetary boundaries. And that's why economy as well as nature are means to fulfill our ends in a sustainable way. So, and MEFA is able to balance and assess those socioeconomic metabolism. But what we are not doing is defining thresholds. So we are not defining the planetary boundaries. And we are also not defining what societal needs are. This is just something which is important to keep it in mind. We are not defining it by material flow management or by sustainability analysis. We are applying that. So let's come to the, or are there any questions at this point? Do you agree or disagree with those definitions, or?
You can't read it, right? Hannah asked what means MEFA. Do you hear me?
Yeah.
What means MEFA? Hannah asked.
Material and energy flow analysis.
Oh, yeah.
Sorry. Okay, if you have any further questions, feel free to ask, but otherwise, maybe, or Hannah's typing. Especially, it would be interesting if you are if you question those definitions a lot, or if you say, "I don't think that these are good definitions," or "I think there is something really important missing." Okay, if not, then we can go on. So let's come from those relations of society, ecology, and economy to sustainability assessment, life cycle assessment, and material flow analysis. You see on the left-hand side the classical three-pillar approach. And when you're doing LCA, you can do environmental LCA, as you know it. You can do social LCA, which I will also present to you in a minute, and maybe you also heard of. And you can do something like economic LCA, which is also oftentimes LCC, so life cycle cost accounting. And environmental, social, and economic LCA are three different methods. Why? This has practical reasons, but it also has theoretical reasons. And the theoretical reasons are that they are based on the three-pillar approach. They have three different methods because social, society, economy, and environmental things are thought of as different spheres which are somehow intersecting, but it's very unclear in the three-pillar approach what the relations are. And the relations are also very unclear in the between the three different life cycle assessment methods. Just to give you an example, I told you about the intersections here. For example, have a look at intersection B and at intersection A. So you have intersections between, for example, environment and economy. And those intersections take place when an indicator comes up where it's unclear for a lot of people, maybe also for the people who are doing the LCA, is it like economic, or is it an environmental indicator, or is it a social indicator or an economic indicator? For example, let's say a popular thing is remuneration. So the wages people are getting. Are wages and remuneration, is it a social thing or is it the economic thing? So that's very unclear oftentimes. And that's why those intersections make a lot of problems in practical LCA, because you actually don't know, is it like part of the environmental LCA or is it more part of the economic LCA? Which method has to be applied to which indicator? That's a big problem in practical terms. And it's not only because of there's a practical reason for doing it so, but it is really it's really a thing of which concept, which configuration of society, economy, and environment you have in mind. And if you have in mind a three-pillar approach, it leads to three different methods, and you have some of the problems which I described. And if you have other concepts in your mind, in your background, then you maybe also get other practical life cycle assessment methods. And for example, the intersection, which is here called A, so society, economy, environment, A in the center, oftentimes we say, okay, if we have A, so if we have society, economy, and environment together in a way, somehow, then we have sustainability. So in practical terms, for example, in Lifecycle sustainability assessments in LCSA, then you just combine the 3 different methods and the 3 different results of those methods with each other. For example, by MCDA. MCDA means multi-criteria decision analysis. So you're just combining them, and then you can make some assumption or some result about what you think is sustainability. So the 3-pillar approach and the 3 different methods have separate systems, they have separate concepts, separate methods, and more or less separate indicators. And the problem is that the intersection between those systems and also the intersection between those concepts between the LCA methods are sometimes unclear. And at the end, the dimensions or the different systems, methods, indicators, and so on and so forth, those different things are at the end additively combined in the MCDA. And this produces also a lot of problems. So let's see if there's maybe a better solution. A better solution would be to take our societal relations to nature concept, as we discussed it before, so that we have societal needs in the center, planetary boundaries around all the things which are limiting our economic activities, and a provisioning system, economy, which relates societal needs and nature. And if you have an integrated concept, which is based on relations, you also can come up with the integrated life cycle sustainability assessment method. So where you have a uniform social, environmental, economic scope and goal, you have integrated production systems, you have an integrated indicator system, and you also get integrated uniform results, which also makes, of course, the interpretation with our understanding of societal relations to nature much more easy than additively combining them by MCDA. And we will have a look in detail how things like that could work. Let's have a look at something which you already should know. So the basis of all LCA or LCSA methods are physical economic systems and material and energy flows. So we have process steps, a production system, which usually starts with resources from agriculture and forestry in case of the bioeconomy, raw materials, processing, conversion, treatment, manufacturing, use, and consumption phase, and at the end, recycling, disposal, or thermal use. And all those activities, all those economic activities have some form of impact or effect on society, nature, and economy. So that means that life cycle activities in bioeconomies are different steps and processes of how renewable resources are converted from the beginning, from the cradle to the crate. So from resource production to recycling and disposal. And the economic boundaries of our LCA are defined by our economic activities. So when we start with a specific company at the point of resources, and we end with a specific company in recycling, then those two companies and everything in between, all the other steps, are our economic boundaries. And we also have geographical boundaries. And geographical boundaries, they are defined by the location of the different companies. So they are defined by the location of the process steps. And in regional bioeconomy, or we speak of a regional bioeconomy, when most of the foreground life cycle activities take place in a specific region. So what it is all about is we want to measure social, ecological, economic impacts in LCA or in different LCA methods, and also in the life cycle sustainability assessment. And we want to measure them by indicators. So indicators are qualitative and or quantitative values which make specific characteristics measurable, and they should allow us to make meaningful conclusions on quite complex relations. So indicators are not only describing like society, ecology, and economic, but those indicators, we should understand them as to give us indications about very, very complex relations which are actually behind it. So we want to try to describe our societal relations to nature, very complex relations, by some meaningful indicators. You can see here that I made a table with society, social needs, or which stands for social needs, economy, and nature and planetary boundaries. And in the boxes, you have some indicators, for example, ecosystem toxicity. So how much poisons we are giving to water, to land, to the air when we are producing things. Or, of course, global CO2 emissions, biodiversity, human rights, wages, working hours, etc. pp. And with a little another exercise, let's try to find allocations for each of those indicators. So now we are trying to put each indicator to one or more categories. So is fossil resource extraction, is it more a societal thing? Is it more an economic thing? Or is it more a nature thing? Human rights, is it more economy? Is it more nature? Or is it more society? And not only this, we not only want to try to make an allocation of indicators to specific categories, we also want to make up our mind which indicator value is more or less sustainable. So, for example, biodiversity is more or less biodiversity more or less sustainable. Resource efficiency is more or less resource efficiency sustainable. Or, for example, working hours are more working hours or less working hours more or less sustainable. So maybe please we come back to the whiteboard. And so I have to end it like this. Yeah. And tools, how to Okay, maybe we go to another slide. Yeah. So, yeah. Does anybody of you know how to clear the whiteboard? Okay. Why can't we clear it? And why can't I just do another slide? If you have an idea, Please say it. Okay. Or maybe I just end the now. Okay. I just had to end the multi-user mode, and then I can clear it all. Okay, so you can, in the meanwhile, please open the PDF of our lecture. So you have the indicators which I showed you a minute ago, that you have the indicators on your hand, that you know which ones we have to put here, because I can show you the presentation in parallel. And I prepared a little table here. Okay. So then feel free to put a box or a circle in here from all the indicators I showed you in the PDF, in the presentation. And yeah, just allocate them to a specific column here, and make a little arrow in the box, which indicates if it's better. So when the arrow is pointing upwards, it indicates that the more the indicator is, the more the indicator value is, the more sustainable it is. And when the arrow is pointing downwards, then it's for the less the indicator value is, the more sustainable it is. So I just give you an example, maybe. For example, something which is, of course, very clear is, oh, no. Of course, it's very clear that CO2 emissions, they have to decrease, and of course it's addressing nature. But of course, CO2 emissions are also addressing our economy, and of course CO2 emissions are also addressing our society, because I will show you at the end that in life cycle sustainability assessments, we also take into account that a global warming is not good for our health, because if it gets hotter, then our life expectation is decreasing. So I give you another 5 minutes for that, and I'll be If you have any questions or you like to discuss it with the others, what you are doing here, then feel free to do so. Okay, I think you're finished, right? So yeah, as far as I can see, you already had some good ideas. But I think just by thinking about all those things, it should be very clear that it's very, very hard to say if working, or I mean, for working hours, it's more or less clear. I mean, it addresses society, it addresses economy, and I'm lucky you say working hours have to decrease to be more sustainable. By the way, with this with this interpretation, you are quite progressive. And of course, gender equality is mainly an issue of society and not so much an issue of economy, but more in regards of that society is shaping economy. So, of course, gender equality is also a part of economy, but society is shaping gender equality. Resource efficiency, of course, has to be higher to be more sustainable. Land use and fossil resource extraction, of course, has to be lower, and so on and so forth. But what you see here is already that you have a lot of relations between indicators and those three categories. So actually for nearly no indicator, you can clearly say, okay, this only addresses nature, or this specific indicator only addresses economy. Actually, it's very hard. And exactly that's why the understanding the relations between economy and society and nature and economy and nature, to understanding the relations, is so important for making meaningful sustainability assessments. Because if you don't understand the relations, you also do not understand which indicator actually describes what. So if you don't have any questions, I would continue. If you would like to have a little discussion or so, please feel free to do so. Okay, so let's proceed with the presentation. So I also made a task here, and you see I come to a quite similar picture. Just only one thing which I saw, of course, for example, water consumption and pollution is as well societal, economy or important for society, economy, and nature. Because if you have polluted water, it also has bad effects on nutrition. Because if you're thirsty, that's not good. And if you're thirsty and you only have polluted water, then that's even worse. So, but you get the main problem here, and you get the main line of thoughts here. So now let's have a look at how actually we are measuring and how we are doing social, ecological, and economic sustainability assessments. And what I show you here is the approach of an integrated LCSA. So we are not looking at doing 3 different methods, but we are thinking about, okay, how can we understand and measure ecological, economic, and social sustainability within one method, within one LCA method, within one concept. So, and first, we have a look here at the standard, the process module. You all know process units and stuff like that. So the process module is one thing which represents a specific activity in production. So, for example, we can make from trees, we can make boards. Yeah. So this is a process module, and the process module entails specific different process units. So you have different manufacturing steps, maybe within one process module. So you have different activities within such a module, but we are not looking at every activity, but we are looking at aggregation. We are looking already at a system of activities. And unfortunately, I cannot do animations in this presentation here at the moment. I don't know why, but that's why you have to get along with getting all the information at once. So, and we have such a process module. And this process module, of course, has inputs. Inputs are, for example, energy, some educts, like raw materials, wood, for example, and also bioeducts. For example, some chemical bioeducts, like glue or other chemicals which we need to make something out of our raw materials. So, and on the other side, our process module has outputs. And outputs are byproducts, our actual product, which we are interested in, and of course also emissions. And all those energy, educt, and bioeduct inputs, as well as the byproducts, products, and emissions as outputs, they are our material and energy flows. And one of the the main product is our functional unit. You already know what a functional unit is. So, but when we are thinking about not only ecological, but also about social and economic indicators and social and economic assessments, we have to somehow integrate them into our life cycle inventory, into our inventory modeling. And we are doing that by adding socioeconomic inputs on the top. So a socioeconomic input is working time and capital. Capital in this way means not only money, so not only like exchange value capital, but also capital of means of production and all this stuff. And what you have to keep in mind in capitalism, also working time, working force is a form of capital. So I show it here as different errors because in LCA we are doing it, we are managing them as different inputs. But keep in mind that in capitalism also working time or working force is part of capital. So and why working time is important is that working time is our activity variable. So we not only have a functional unit, which we need for balancing, we also have an activity variable. And an activity variable is there for relating our process output to the at-all process activities. And those activity variables, they are reflecting the share a given activity has or the share which each process module has in the whole production process for social impacts. Because we say our assumption is that social impacts are mainly allocated by the amount of working time or the number of people which are actually working there. Just to make it clear in a second, when you have a look at the bottom with the ecological, social, and economic indicators. So here we are measuring like the effects by indicators, and we have social, ecological, and economic ones, and X-Ecol or X-Soc and X-Econ, the X's are the indicator values. And if you want to make an allocation of the ecological, social, or economic impacts in our production system, we have to find those allocation variables by functional units for ecological and also economic indicators, and by activity variable for social activity or for social impacts. This is the case because if you would not include working time here, you would say you are making the assumption that our social effects are as big as our material and energy flows. But this is not correct because imagine a process module or a process unit or a product system which is highly automized. If you have a highly degree of automation, then of course the social effects are much less than for process modules or process units which require a lot of working time. Okay, so see it as the inputs, energy educts, by-educts, and the outputs, byproducts, products, emissions. Of course, for exothermic processes or process units, also energy can be an output. And see it as socio-economic inputs, as working time, as our activity variable, and capital, and effects, and which are measured by indicators, and they are like here the output, and we have social, ecological, economic indicators, effects. We are measuring them, and the value we get out of our measuring is the X. When we are measuring indicators, we are producing data, and this data is our inventory data. And there are a lot of different types of inventory data. So, for example, we have different output types. Output types of inventory or indicator data can be quantitative data. That means we are expressing a certain quantity, amount, or range. We have qualitative data, which stands for attributes of an object. And those attributes can be categorized into classes, and we may assign numeric values to them. So, for example, you can say think of the indicator human rights. Yeah, you can say human rights. You can also maybe measure them by quantitative data, but assume we would measure human rights just by are human rights guaranteed or not. So we are measuring them by yes or no. Then we are categorizing attributes of yes or no into classes, like sustainable, not sustainable, yes, sustainable, not sustainable. And we can also assign numeric values to yes or no. For example, we can assign a 1 to a yes and a 0 to a no. At the end, we cannot calculate with, we cannot do statistics with those assigned numeric values, but it helps us to go further with it, to aggregate them, and so on and so forth. So we have quantitative data, we have qualitative data, and we have semi-quantitative data. Semi-quantitative data is exactly those indexes or other tools where you don't have like natural quantitative things, but for example, a mix of quantitative data and qualitative data which we assign to numeric values. We also have different levels of resolution. So we can have a look at company data, which is of course a whole company, but not site specific. So we can look at Nestle, for example, as a whole company, but we are not looking at Nestle in Hanover or so. We have site specific data, which stands for a specific production activity and process. So you can say here, we not only have Nestle, but we have Nestle in Hanover. And we also have generic data, and generic is public and statistical data. So you not have it for Nestle and you not have it for Hanover, but if you are interested in data for the whole industry of producing nutrition, drinks, and all other goodies here, then you have public and statistical data. So they are standing for whole industry. And we also have the source of collection. We have primary data. So primary data is data which we collect and manipulate by another. There's a error here. So primary data is collected and manipulated by ourselves, and we're getting it directly from an institution. And secondary data is something which gets collected and manipulated by a third party. So, for example, generic data is always secondary data. And if we come to the life cycle impact assessment, so where we actually think about, okay, which impact has a specific indicator, so where we say actually is the indicator sustainable or the indicator value sustainable or not, we have two different methods. One different method is the reference scale life cycle impact assessment and the impact pathway life cycle impact assessment. The reference scale impact life cycle impact assessment is that we are assessing sustainability by its performance based on a specific reference we choose. So that means, let's keep the example of Nestle. If we assess Nestle, then we assess Nestle as a specific company, or maybe we take Nestle in Hanover and we assess Nestle in Hanover as a specific company with a specific location compared to a reference. And the reference can be, for example, all other countries, all other companies which are producing nutritions in Germany. So this can be our reference. So we have a specific case which we are looking at. We have a specific indicator, XI, This is our specific indicator value we have from our life cycle assessment, from our inventory, and we are comparing it to all the other companies which are also active in this field. So we have a statistical representation of our reference, and this statistical representation is a rating function. And you can imagine it, it's a little bit a complex process, but you can imagine rating functions stand for all the references. It's a statistical background here. And on this statistical background, we can say that, for example, if we have an indicator value xi, and we put it as an input in our rating function here, we get an output. And this output ri, dependent from xi, this is our rating value. And this rating value is expressed as performance reference points. For example, 5 or 10 or 1 or 2. So it's a scale, and it's a scale without units. And this scale can reach from example or imagine from 0 to 10. So we get an indicator, or we get a performance, for example, a social performance, by producing performance reference points. So we are producing a scale from 0 bad till 10 good, for example. And so we make our assessment, our impact assessment here, by saying on a scale from 0 to 10, our indicator value is good or bad. And every time compared to a specific reference. If you are interested in how it works in detail, you can also have a look at the literature, but I don't want to go deeper inside here. Important is, if you are doing a reference scale LCIAs, you have no quantitative cause and effect chains. So, for example, think about an indicator like working hours. If we are doing it with this rating function here, we just have statistical data on how much working hours do have all the other companies, and we have a specific data on how much working hours do we have in our company we look at. But at the end, we are comparing our indicator to a reference, and we are making a sustainability assessment. But what we are not doing is we don't think about cause and effect chains of how does actually working hours are related very specifically to society, economy, and so on and so forth. So we have no quantitative cause and effect chains. We have to understand what how working hours are set up, and we have to understand how working hours are influencing society and economy, and how economy and society are influencing working hours. So we have to, of course, we have to understand the politics and the social relations to nature behind working hours, but it's not our modeling. Our modeling is independent of the understanding of cause and effect chains. And this applies mostly to social indicators. And of course, it's clear why. Because social indicators oftentimes don't have clear quantitative cause and effect chains. They have qualitative cause and effect chains. Because society or social indicators are mostly qualitative entities, are mostly qualitative things, and it's very hard or impossible to describe them quantitatively by quantitative relations. It's better to understand them qualitatively. And on the other side, we have impact pathway LCIs, and impact pathway life cycle impact assessments are the opposite. So here we assess sustainability really as causal or correlational relations. So we know exactly how quantitatively a specific indicator has effects on, let's say, specific impact categories, and we exactly know the relations and we can quantify those relations. For example, have a look at the CO2 emissions. This is impact pathway life cycle impact assessment for CO2 emissions and the life expectancy and diminished quality of life. So that means how CO2 emissions are impacting life expectancy and the quality of life. And here you can see how impact pathways are concepted. So you have global greenhouse gas emissions. You have, of course, the increase of those emissions. This increase of global greenhouse emissions leads to increased radiative forcing. That means we have more radiation. And this increase in radiation, or in the reflection of radiation, this increases the global mean temperature. And the increase of global mean temperature, for example, changes diseases or flooding. And of course, this damages our human health. Or for example, they also damage terrestrial species. So they are not only damaging humans, but they are also damaging animals or plants. So we can exactly by mathematical relations, by really science, a lot of sciences which is behind those impact pathways, we can quantify how many kilograms of CO2 we are emitting are leading to a specific endpoint impacts. And that's why they are also called midpoint and endpoint impacts, because midpoint things are just like the, so the indicator is greenhouse gas emissions. The midpoint indicator is something like the increased radiative forcing, and the endpoint indicator is the effect it really has, increasing global mean temperature and damaging human health. So behind impact pathways, life cycle impact assessments are quantitative cause and effect chains. And those quantitative cause and effect chains are mostly ecological ones. Why? Because natural science allows us to really mathematically understand how much CO2 emissions are leading to how much increase in global mean temperature. And we know from also health and biodiversity sciences what is the effect on human health, or, for example, biodiversity and the disappearance of terrestrial species. So we have reference scale LCIA and impact pathway LCIA to make the impact assessment of our different indicators. And the last step is weighting and aggregation. Have a look at the top. So we have here our indicators: human rights, right of association, resource efficiency, and so on and so forth. With the indicator values, we are going into our life cycle impact assessment. And this can be a reference scale life cycle impact assessment or an impact pathway life cycle impact assessment. And afterwards, we can go with our rated impact assessment values into weighting. So we can make a weighting, for example, for just the equal weighting. So equal weighting means all indicators get the same weighting. We can do a weighting for robustness, so that we say, okay, we rate the indicators higher, which have a very robust impact assessment method, for example. We can also do a weighting by participation. That means we let stakeholders or society or participants of our study decide how much we want to weight different indicators. And we can also do a hotspot weighting, so that we say we know which indicator performs really bad, and that's why we are giving it a high weighting to make clear in the results that there are things which have to be improved. So, and then you can also go into different categories you are assigning the indicators to. So, for example, you can go for the SDGs, and at the end, you can go for our society, economy, and nature categories. And coming and weighting is the thing here in the middle. So, equal robustness, participation, hotspot weighting. And aggregation is the process from getting from the indicator value to an indice. So with every step we take, from indicators over impact assessment to like the final categories, we are making an aggregation, and we are simplifying our model, and we also are simplifying or condensing our results. So this is very important for making them actually communicatable to people which are not LCA experts. And at the end, we also have to make the interpretation. You already know that from standard LCA. So we have to perform completeness, consistency, sensitivity, and data quality checks to make our study robust and reproducible and also comparable. We should discuss how our indicators are actually influencing social, ecological, and economic sustainability. So which risks and chances does our production system has? We also have to look at which process steps are most relevant for impacts. And our focus in social, ecological, and economic life cycle assessment is, of course, are there contradictions or trade-offs between those different issues? At the end, of course, our study should be able to address questions of governance, for example. So that means to identify really specific fields of potential action and regulation. So are there possible conclusions and solutions we can propose for the people who are paying us to do those studies? For example, politics, that they can get an answer for their question on how to fund or how to make laws for specific economic activities to improve sustainability at the end, hopefully. So at the end, we have to define questions which we want to answer by our study. And it's important to check in the interpretation if we can answer those questions in a reliable, relevant, clear, transparent, and accessible manner. So, and of course, in interpretation, it is very important to keep in mind that there are limits of our assessment here. And one limit of our assessment is that, of course, also achieving a sustainability in bioeconomy is limited as long as sustainability is not a central objective or even a contradiction of our general economy and our social relationships to nature. So, for example, you cannot achieve sustainability by bioeconomy if you add bioeconomy on top of the fossil economy. Then you are just producing more impact than before, and so you don't achieve any absolute sustainability benefits. So I give you now a little example of a case study which we did on the integrated and holistic life cycle sustainability assessment of laminated veneer lumber. This is a product which you are using in the building sector. So it's a forestry or a lumber product. And here you can see the product system. So the product system takes place in our geographical boundaries. That's central Germany in this case. And for example, we start at the hardwood forestry. We have to transport our saw logs to the LVL manufacturing by a specific process in between. So these are typical diagrams, typical graphs of production systems from, you already know it from OpenLCA. So here we have our foreground and our background activities. Foreground activities are exactly those activities which take place in our specific region and which are mainly going into our functional unit, into our product we want to access. But of course, we also have background activities like the electricity production or the production of bioeducts, chemicals. In this case, we need phenolic resin as a glue for gluing together those those veneer sheets. So we have a background and a foreground system here. And now we are making the inventory. So, for example, we want to produce one unit of those laminated veneer lumber. For this, we need 1,200 kilograms of wood. We have to transport it 100 kilometers. And at the end, we have to do this production of these veneer sheets, gluing them together, etc. pp. And at the end, we are getting a product which weighs our functional unit of laminated veneer lumber, which weighs 1,400 kilograms. But we also, of course, need electricity and we need chemicals. For example, we need 260 kilograms of phenolic resin to produce this functional unit here of 1,400 kilograms of laminated veneer lumber. So this is classically the ecological and economic LCA. But we also want to do social LCA. So we have to not only make our mind about the social effects, but we also have to have a look at the working hours. So, for example, you can see here that we have 0.7 working hours for one laminated veneer lumber thing in the forestry. And we have a lot of working hours in the background activities as well. And at the end, we take 9.08 hours to produce one of those laminated veneer lumber bars. So this is our background and foreground activities with the functional unit and the activity variable. And the activity variable at the end is 70.2 hours. So at the end, 70.2 hours are required to produce our functional unit, which is 1,400 kilograms of laminated veneer lumber. And of course, this production system has social, ecological, and economic effects on our planetary boundaries, provisioning system, and social needs. And we are measuring them by indicators with values, X, and so on and so forth. This is our goal and scope system, our model, which we are looking at. Then we have an inventory. Inventory are our indicators. So we have a sustainability framework. That's the sustainability framework we discussed before, social needs, the provisioning system, economy, and the planetary boundaries. We are addressing the SDGs, and we have indicators. For example, we have 20 indicators for social needs. We have 40 indicators for ecology and for the economy and the provisioning system. And we have 20 indicators for planetary boundaries. We get those indicators from different life cycle impact assessment methods. So in OpenLCA, you can assess different life cycle impact assessment methods, which are, let's say, making a lot of work easier for you, because the impact assessment methods are doing, for example, the the reference scale or the impact pathway impact assessments for you. So you don't have to do them manually. Of course, we have qualitative and quantitative data, and we use functional units and the working hours as activity variables. And you get indicators which are very similar to the examples we discussed before. For example, land use, climate change, fossil resource scarcity, things like that. In the impact assessment, we now have to decide what general result do we actually want to produce? What do we actually want to assess? And we are doing here, in this case, relative sustainability assessments. So that means we are comparing the relative sustainability of those laminated veneer lumber beams compared to steel beams. So we are comparing them because they are able to be compared, because they have a similar functionality. For example, an average bending capacity. So they are fulfilling the same purpose. And one of the LVL beams weighs 1,469 kilos. So that's our functional variable. And one of these steel beams weighs 1,720 kilos. What we are doing now is for every product system. So at the one hand side, we have a product system for the LVL, for the wood beams, and we have a product system for the steel beams. For every product system, we are calculating the indicators, and we get indicator values of the total product system. So, for example, the total CO2 emissions for producing LVL and the total CO2 emissions for producing a steel beam. And we can do a normalization by calculating dimensionless factors. For example, substitution factors of impact. So those substitution factors of impact can tell us how is the relative sustainability of wood beams and steel beams. And of course, from all substitution factors for each of the impacts, we can calculate substitution factors in total, which make like the general assumption or the general results for how more or less sustainable is wood compared to steel. Those substitution factors have different risk levels. So they are ranging from a very low risk to a very high risk. For example, a substitution factor which has a value of 0.1 is, of course, a very low risk level. And you will see why in this example here. This is the example for climate change. Have a look. This is like the real world data now. When we are producing one of the LVL beams, then we are emitting 1.5 tons of CO2 equivalents. If we are producing a steel beam, which fulfills the exact same functionality, we are emitting 3.8 tons of CO2. So that means our substitution factor of impact is 0.39, or to say it in other words, we have a low risk because we only emit like less than half of the CO2 as when we are using LVL beams as if we would use conventional steel beams. So in this case, for CO2, LVL, the wood beam, is much more sustainable than the steel beam because we are emitting 0.39 the CO2 emissions we would have in the conventional case. So, and this we can do for every indicator. And you get results like this. So you see again the societal needs, the provisioning system, and the planetary boundaries. And for every of the SDGs, you can see that we have impact factors. And our total impact factor or our total substitution factor is 0.62. That means for all social, ecological, and economic impacts, LVL beams are less unsustainable than steel beams in most terms. We can also see that 70 indicators are have a substitution factor below 1. That means we have a low risk. And even 56 indicators have a substitution factor between below 0.5. So from 56 out of 74 indicators, LVL has half the impacts of steel, which is quite good. But we also have some significant risks. For example, have a look at the land use, SDG 15. SDG 15 has in total a substitution factor of 2.14. And this comes from a specific indicator, which is land use. We have 18 times the land use when we are using LVL than we have when we are using steel. Of course, because wood has to grow somewhere, and iron ore we are getting from minery. So we have a very high impact on land use when we are using wood beams. And this is exactly why planetary boundaries, for example, how much area we actually have for our economic activities, are so important. Because if we have 18 times the land use if we use wood, then of course our production of wood and LVL is limited because our planetary boundaries are limited. So to wrap it up, the substitution of steel beams by LVL beams can make a significant contribution to sustainability and the SDGs, but it would be even more sustainable when fossil components like the phenolic resin, which is a fossil component, are also substituted by renewable alternatives. And this is very striking. 70 out of 74 indicators, for 70 out of 74 indicators, phenolic resin is the main contributor of negative impacts. So if you would avoid phenolic resin in our LVL, this would already increase the overall sustainability of our product by far. So, and what we can say, for example, for the high land use, of course, it is very important for our LVL production that we reduce land use and that we reduce negative land use changes. So, for example, we can say, okay, we produce LVL to a limited amount, but all of the wood we use for LVL should come from FSC certified wood. This would be like our policy recommendation. So, and that's something like a case study on this. And if you're interested in some of the literature, so for the fundamental problems, but also for the specific social and LCSA application, you can have a look at the literature. And now we have also some time left for questions. So I hope you are still awake. And yeah, if there are any questions, let's discuss it. I know that it's hard in the online seminars and that there are not so much questions coming, but yeah, feel free. Otherwise, we have more spare time at the end.